Well, we are calculus students, and those parametric curves that we looked at in our last lesson, they were smooth. And smooth curves have derivatives. So we take a look at how to find the derivative of a curve with parametric equations in this screencast. Here's the big takeaway. When you are looking for the slope of the tangent line, y in terms of x, that slope of a tangent line is the derivative of y with respect to t divided by the derivative of x with respect to t. Why? Well, the chain rule says, you remember the chain rule from Calculus 1, right? The chain rule says that if you multiply dy dx times dx dt, you get dy dt. And since we want dy dx by itself, this result very quickly follows. When we want dy dx, the slope of the tangent line, we find dy dt and divide by dx dt. So for the parametric curve, where x has equation t cubed minus 12t, and y has equation t squared plus 4, find the slope of the tangent at the point 1620. Well, that's easy. Slope of the tangent, that's dy dx. dy dx is dy dt over dx dt. Well, dy dt, that's the derivative of y, that's 2t. And dx dt, well, that's still not bad. dx dt is the derivative of x, that's 3t squared minus 12. And all we have to do is evaluate, well, there's got to be some t that generates 1620. If t squared plus 4 is 20, then t is either 4 or negative 4. But if t cubed minus 12t is going to be 16, well, that means that t has to be 4. Okay, so we do this at t equals 4, and we get 8 over 36, which is easily 2 over 9. That's the slope of the tangent line. We can find the equation of the tangent line. It doesn't really matter. But we're asked for the slope, and that's what we found. The thing that we note here as an aside, let's bring in our first side note. The thing that we note as an aside here, the side note, vertical tangents will occur when dx dt is 0 and dy dt is not. Why? Because that makes the denominator of a fraction 0 and the numerator of the same fraction not 0, and so the slope of the tangent would be undefined. And similarly, horizontal tangents will occur when dy dt is 0 and dx dt is not, because the numerator of a fraction will be 0 and the denominator of that fraction will not be 0, so the slope of the tangent line is 0. That's a nice thing to tuck away. I will bring in, at this point, we should talk about second derivatives. How do you find the second derivative of a parametric function? Well, the second derivative is the derivative with respect to x of the first derivative. So how did we take derivatives? We took the derivative of whatever this was with respect to t, and then divided by dx dt. And that's what happens here. We take the derivative of y prime with respect to t and divide by dx dt. So, for example, for the curve with parametric equations, x equals 4 minus t squared and y equals 6 plus t to the fourth, find dy dx and the second derivative. Well, how do we do that? Well, dy dx is dy dt over dx dt, which in this scenario, dy dt over dx dt, which happens to be negative 2t squared. The second derivative is the derivative of y prime with respect to t over dx dt, which in this case is the derivative of y prime with respect to t over the same dx dt as before, and that happens to be 2. So the second derivative for this particular parametric curve is always 2. Always. One more. Find all horizontal and vertical tangents to the curve with parametric equations x equals t squared minus 4t and y equals 2t cubed minus 6t squared. Running off of our side note from earlier, horizontal tangents occur where dy dt is 0 and dx dt isn't. So dy dt, oh, that's wrong. Dy dt is 0 when 6t squared minus 12t is 0. A little bit of algebra gives us 2 values of t. Now, vertical tangents occur when dx dt is 0 and dy dt isn't. Dx dt is 0 when 2t minus 4 is 0, so t is 2. Notice, if t is 2, dx dt is 0, but also dy dt is 0. So there are no vertical tangents because there is no value of time that generates a dx dt of 0 and a dy dt that isn't 0. There is one horizontal tangent, and it happens when t is 0. When t is 0, the y value is 0, and so y equals 0 is a horizontal tangent. Not because this number is 0 is this number 0, but because this number is 0, the y value is 0, and that's a 0 there. It's not just that whatever this time is ends up here. Whatever this time is determines a y value, that y value goes there. Okay? Okay. I hope that this is helpful to you as you find derivatives and second derivatives of parametric curves.